Hi, this is Talhanas. Today I will tell you about Picard's method. It is a numerical solution of ordinary differential equations. It is an iterative method. In this video, you will learn about the basic concepts of differential equation, also the solutions of differential equation, initial and boundary conditions, and our major topic, Picard's method for solving ordinary differential equations. Differential equations. What differential equations are? A number of problems in science and technology can be formulated into differential equations. The analytical method of solving differential equations are applicable to a limited class of equations. These methods are even greater importance than we realize that computing machines are. Now coming to the solution of differential equations. The solution of an ordinary differential equation means finding an explicit expression for y in terms of a finite number of elementary functions of x. Such a solution of a differential equation is known as the closed or finite form of solution. In the absence of such a solution, uh, we have recourse to numerical method of solution. In most of these methods, we replace the differential equation by a difference equation and then solve it. These methods yield solutions either as a power series in X form which the values of y can be found by direct substitution, or a set of values of x and y's. The method of Picard and Taylor series belong to the former class of solutions. In these methods, y is approximated by a truncated series, each term of which is a function of x. The information about the curve at one point is utilized and the solution is not iterated. As such, these are referred to as single step methods. Now, what is initial and boundary conditions? An ordinary differential equation has a particular solution. Therefore, as many constants there are we should given the conditions according to the constants in the ordinary differential equations. If these conditions are prescribed at one point only of the nth order, then they are termed as initial value problem. If these conditions are prescribed at two or more points, then these problems are termed as boundary value problems. Now coming to our major point, our major topic, which is Picard's method. In Picard method, we iterate the ordinary differential equation several times. As you can see in this animation, as many iterations we do, our error will be minimized and we will be closer and closer to our original solution, exact solution. The differential equation we are interested in studying is y prime is equal to function of t and y, given that y of t naught is equal to y naught. Many first order differential equations fall under this category. The following method is a new method for solving differential equations, which is Picard's method. The first idea is to transform the differential equation into an integral equation. Then apply a new method to integral equation. We first do a change of variables to transform the initial conditions to the origin. Explicitly, you can define w equals to y minus y naught, and also x is equal to t minus t naught. With a new function, the differential equation we will study is given by y prime is equals to function of t and y, given that y of 0 is equals to 0. But the point here is, if we have a very simple function, we do not change or transform uh, our variables or our equation into variables. There is no such need of doing this. Now we integrate the equation from s is equal to 0 to s is equal to t to obtain this equation. Then we will apply the fundamental theorem of calculus, which we commonly call to solve or uh, uh, to solve the differential equations, we normally say in our calculus or differential equations. Hence, we reduce the differential equations to an equivalent integral equation by this. The expression is given. Now, this looks like it is solved, but isn't it? We have y in this. The y variable is extra, so that we can't integrate it. So we introduced a new method called Picard's iterative method. What we do in this, we choose an initial guess y naught of t to equation above. For n is equals to 1 2 3 4 5 and so on, set y of n plus 1 is equals to integral of function of s and yn of s and integral operator ds. If we stop this algorithm at a finite value of n, we expect yn of t is to be a very good approximate solution of two differential equation. This makes this method of iterative an extremely powerful tool for solving differential equations. Problem solving by Picard's iterative method to solve ordinary differential equations. For a concrete example, I will show you how to solve the problem. Use the method of Picard's iteration with an initial guess of y naught of t is equals to 0 to solve y prime is equals to 2 y plus 1, given that y of 0 is equals to 0. Note that the initial condition is at origin, so we just apply the iterations to this differential equation. The equation is given, hence we got y1 here. The value of y1 is equals to 2t by solving this. Then we will get to more accuracy by another iteration, y2. The value of y2 comes out to be something like this: 2 square upon 2 factorial multiplied by t square plus 2t. Then we iterate it first time. We iterate until we do satisfy our answer. It looks like the pattern is something like this, and hence the exact solution is given by this equation. If you plug this into a differential equation, you will see we hit this one on the money. Now this figure demonstrates the difference between approximate and exact solution. You can see here it is quite uh, closer to exact solution. You can see the red circles here. These circles represents the approximate solution. Hope you enjoyed the video. For any queries, feel free to contact me at given email address. Thank you. Hi, this is Talhanas. Today I will tell you about Picard's method. It is a numerical solution of ordinary differential equations. It is an iterative method. In this video, you will learn about the basic concepts of differential equation. Also, the solution